Have you ever looked up at the sky and watched a massive airplane soar effortlessly through the air? It's a sight that never gets old, a testament to human ingenuity. But have you ever stopped to wonder, what makes that incredible machine fly? The answer lies in the heart of the aircraft, the jet engine. Jet engines are marvels of engineering, transforming fuel into immense power that propels airplanes, helicopters, and even some rockets. They are the driving force behind modern aviation, connecting people and places across vast distances. Without jet engines, our world would be a much smaller place. Imagine a world without transcontinental flights or international travel as we know it. Jet engines have shrunk our globe, making it possible to experience different cultures, visit distant loved ones, and conduct business on a global scale. In this exploration, we'll unravel the mysteries of jet engines, delving into the core principles that allow these incredible machines to power the skies. Like humans, jet engines need to breathe to function. But instead of lungs, they have an intake, the starting point of our journey through the engine. Imagine the intake as a giant mouth, gulping in vast amounts of air as the aircraft moves forward. This air doesn't just sit there, it has a vital role to play. It's the key ingredient in the engine's operation, the lifeblood that gets transformed into thrust. The design of the intake is crucial. It's carefully shaped to smoothly guide the air into the engine, ensuring a steady and efficient flow. Think of a funnel, guiding water into a narrow opening without any spills. The intake does the same for air, preparing it for the next stage of the journey. Once the air enters the engine through the intake, it encounters the compressor. This vital component is the muscle of the operation, responsible for increasing the air pressure. Picture a bicycle pump. As you push the handle, you compress the air inside, making it denser. The compressor in a jet engine works similarly, but on a much grander scale. It's comprised of multiple rows of spinning blades, resembling small wings attached to a central shaft. As these blades rotate rapidly, they squeeze the incoming air, forcing it into a smaller space. This compression is essential because it increases the air's potential energy, making it primed for combustion in the next stage. Now let's move to the heart of the engine, the combustion chamber. This is where the magic truly happens, where the compressed air meets its fiery destiny. Fuel, typically kerosene-based jet fuel, is injected into the combustion chamber and mixes with the high-pressure air. This volatile mixture is then ignited by a continuous spark, creating a controlled explosion. Imagine a gas stove. When you turn the knob and click the lighter, the gas ignites with a whoosh, producing heat. The combustion chamber operates similarly, but on a much larger and continuous scale. This continuous combustion generates an immense amount of heat energy, causing the air to expand rapidly and transforming it into a high-speed, scorching hot gas. Section 5. Spinning to fly, the turbine. The hot, expanding gas from the combustion chamber doesn't just dissipate, it has a crucial job to do. This is where the turbine comes in, the workhorse of the jet engine. Think of a windmill. The wind's energy causes the blades to rotate, generating power. The turbine works in a similar way, but instead of wind, it's driven by the force of the hot, expanding gas rushing through it. The turbine is connected to the compressor by a central shaft. As the hot gas spins the turbine blades, it also rotates the compressor, drawing in more air and sustaining the engine's cycle. The turbine extracts energy from the hot gas to power the compressor. It's a remarkable display of energy conversion, turning heat into mechanical power. Section 6. Blasting off, the exhaust nozzle. We've reached the final stage of our journey through the jet engine, the exhaust nozzle. This is where all the energy generated by the engine is finally converted into thrust, the force that propels the aircraft forward. The exhaust nozzle is a carefully shaped tube at the back of the engine. The hot, high-speed gas from the turbine is channeled through this nozzle, accelerating it even further. Imagine a garden hose. When you cover part of the opening with your thumb, the water shoots out with greater force. The exhaust nozzle works similarly, constricting the flow of gas and increasing its velocity. As the high-speed gas exits the nozzle, it creates a powerful thrust force in the opposite direction, propelling the aircraft forward. This is Newton's third law in action. For every action, there is an equal and opposite reaction. Section 7. A family of engines, turbojets, turbofans, and ramjets. The jet engine isn't a one-size-fits-all solution. Over the years, engineers have developed different types of jet engines, each optimized for specific applications. The turbojet is the original jet engine design, relying solely on the exhaust gas to generate thrust. It's lightweight and powerful, ideal for high-speed, high-altitude flight like supersonic jets. The turbofan engine is a variation of the turbojet, featuring a large fan at the front. This fan bypasses some of the air around the core of the engine, increasing fuel efficiency and reducing noise, perfect for commercial airliners. The ramjet engine is the simplest of the bunch, lacking any moving parts. It relies on the aircraft's high speed to compress the incoming air, making it suitable for supersonic and hypersonic flight. Section 8. Jet engines powering our skies. From the moment an airplane takes off to its graceful landing, the jet engine is the unsung hero, tirelessly working to conquer gravity and connect our world. We've explored the intricate workings of this remarkable machine, from the air intake to the exhaust nozzle. We've seen how each component plays a crucial role in the engine's operation, transforming fuel into thrust. Jet engines are a testament to human ingenuity, a marvel of engineering that has revolutionized travel and shrunk our globe. They have opened up a world of possibilities, connecting people and cultures across vast distances. Section 9. A look ahead, the future of flight. As we look to the future, the quest for even more efficient, powerful, and environmentally friendly jet engines continues. Engineers are exploring innovative designs, such as geared turbofan engines that offer improved fuel efficiency and reduced emissions. New materials and manufacturing techniques are constantly being developed, paving the way for lighter and more durable engines. The dream of supersonic and even hypersonic air travel is also within reach, driven by advancements in jet engine technology. Imagine flying from London to Sydney in just a few hours. The possibilities are limitless. The journey of the jet engine is far from over. As technology advances, we can expect even more groundbreaking innovations that will continue to shape the future of flight and connect our world in ways we can only imagine.